Everyone, in today's session I'm solving the fifth problem on module 2. So this is the given problem. It is quite different when compared to the all previous problems. So observe here. So we have a generator or the alternator is there. It is connected to the feeder, nothing but a transmission line, which is having the series reactance of 0.12 plus j 0.48 ohm, and the length of the feeder or the transmission line is 15 kilometer. So here we have a transformer is there. So that is having the rating as a 3 MVA 6.6 kilovolt slash 33 kilovolt. So here we have to find out the fault current supplied by the generator, which is operating under no load condition. So that means it is clearly given in the problem. The given system is unloaded system, but they have given the one important parameter, that is 6.9 kilovolt. So what is the 6.9 kilovolt means? This is the rating of the generator. So we can consider 6.9 is the generator terminal voltage. Very important, remember this. So then a three-phase symmetrical fault occurs along a 15 kilometer transmission line or the feeder. So here you can observe this is the point where a three-phase symmetrical fault occurs. So now in this problem we need to calculate only the subtransient fault current in actual, that is in amperes. So this is what the given problem. So now before proceeding with the step, I'll write the rating of all the components so that it will be easy for the calculation. Now proceeding with the step, since in the problem it is not mentioned which component to take as a base, so it is understood that we need to consider the generator rating 5 MVA and 6.6 will be the base voltage. By taking 6.6 as a reference, we need to calculate the base voltage of the transmission line or the feeder, since it is on the HT section. So here I can observe MVA base new is 5 MVA of the generator and the base voltage is also of the generator only. Now this is the reference value. By considering this reference, we'll calculate the base voltage of the transmission line or the feeder. So using a HT section formula, we obtained the answer as 33 kilovolt. So after this, next we are going to calculate the per unit reactance for the generator, transformer, and also calculating the impedance for the feeder. Now we can observe in the reactance calculation of the generator, X per unit volt is 0.08 and the volt and nu will be same, and also the voltage is also same for the generator. We got the answer as J 0.8 per unit. Similarly I have done for the transformer. You can just look at the calculation. So here I have considered the primary side 6.6. This is connected to the generator and the new value of the generator is 6.6. Same way if you cross check for the secondary means 33 is the volt value connected to the feeder, that is having the value as 33. So you will get same answer on both the side. So next we are going to calculate the impedance of the transmission line. Why I have written impedance means because the ratings of the transmission line or the feeder is given as R plus J into X. So that is why I have written the per unit impedance of the transmission line. So now you know the formula, X in ohm or Z in ohm multiplied by MVA base nu by kilovolt base square nu. But here the distance also need to be considered along with the given impedance. So how I can write as 0.12, this is the given impedance in the problem, 0.48 multiplied by the length of the feeder or the transmission line is 15 kilometer, again multiplied by MVA base nu, that is step 1, 5 MVA divided by kilovolt base square nu of the transmission line, that is 33 whole square. So after this calculation, I have obtained the answer for Z per unit nu is 0.0083 plus J into 0.033 per unit. So this is the per unit impedance for the transmission line or the feeder. So the next thing is we need to draw the per unit reactance diagram. So I have written the reactance diagram from the given one line diagram. Observe here. So this is the generator connected to transformer and we have an impedance of the transmission line is there. So this is the impedance, and here there is a occurrence of a three-phase fault. So that we can represent separately here. So this is the occurrence of three-phase fault. So next we are going to proceed with the pre-fault calculation. So in the step 2, before proceeding for the calculation, one important thing you have to observe, even though the fault is occurring on the generator, that is on the transmission line or the feeder side, and this feeder, it is not connected to any parameter. So what given data in the problem is, they have mentioned VGT value. So in such a case, how do we find out the V pre-fault value means? So now in the given reactance diagram or the impedance diagram, first we have to write the expression for VGT first, because this is the value mentioned in the given data. So now how do you write the expression for VGT means? Now observe here, this is the generator terminal VGT, and the load current flowing in the system is IL. Next, this is the pre-fault, because here the fault is occurred, so consider this will be the pre-fault voltage. So now we will write the formula for the VGT. So it is VGT in per unit will be equal to, so after that we have a load current IL is there, and that is been going into all the reactances, reactance of the generator, reactance of the transformer, and we have impedance of the transmission line or the feeder is there. After that we have the V pre-fault voltage that is present, and that should be expressed in per unit. So you know that in the problem itself it is clearly mentioned this is an unloaded system. So in such a case what happens, if there is no load is present, then what will happen? So the load current, so the load current also will be equal to 0. So now consider IL is equal to 0. Why means it is an unloaded system. So such a case what happens? IL is 0. 0 multiplied with all the reactance will be equal to 0. So now we can write the expression for VGT in per unit as it is VPF in per unit. So remember this, very important. So when do we consider this condition means, in the problem the transmission line or the feeder, it is not connected to any other component, and they have mentioned the terminal voltage of the generator. So then we have to consider VGT will be equal to V pre-fault voltage, that is VGT will be equal to V pre-fault voltage, because the load current is 0, all the reactances will be equal to 0 only. So now based on this we will write the formula for the V pre-fault voltage. So observe here, VGT in per unit will be equal to VGT actual divided by VGT base. Understood? We have considered VGT will be equal to V pre-fault. So instead of writing V pre-fault actual and base, we have written with respect to generator only. So you know the VGT value actual given in the problem, that is 6.9 kilovolt divided by VGT base, that is the generator base voltage given in the step 1 is 6.6 kilovolt. So now after this calculation we will obtain VGT value as 1.045 per unit. So now this VGT per unit value is also equal to VPF per unit value, that is equal to 1.045 per unit. This is very important step. So after this, next we are going to proceed with the step 3, that is fault current calculation. So now for the fault current calculation, IF per unit is VTH by ZTH. VTH is nothing but VPF, nothing but 1.045. So next we need to find the ZTH. So how do we find ZTH means, the same impedance or the reactance diagram we need to rewrite by neglecting the source voltage and consider this as the short circuit, so or a closed circuit. So this is the circuit of the same reactance diagram. So here we have ZTH is there. So now observe here, all these reactances are connected in series. So after adding all the reactants which are connected in series, we will obtain the ZTH value. So I'll write the final answer 0.08, one more 0 is there, 83 plus J 0.019 per unit. So this is the answer for the Thevenin impedance, that is Z. So you need to add all the 3 reactances here. So after getting ZTH value, substitute that in the fault current formula. So VPF is, or VTH is 1.045 divided by this reactance 0.0083 plus J 0.019. So I'll get the final answer as 0.23 minus J 5.404 per unit. So almost we're done with the problem. Only thing we need to convert this fault current, it is expressed in per unit and it is need to be converted into actual. So now coming to the last step, actual fault current calculation. IF double dash actual is equal to IF double dash per unit into I base. So this answer we already obtained from the last step. I'll write the answer 0.23 minus J 5.404 into I base is nothing but, you know the formula, P base divided by root 3 into V base. So which base voltage you have to consider means, now look at the one line diagram. Since the fault is occurs along the transmission line or the feeder, so we need to consider the base voltage of the feeder, nothing but the transmission line only. So that is 33 kilovolt. So here you can write P base is nothing but the base chosen in the first step 5 MVA into 10 power 6 divided by root 3 into V base is nothing but the base voltage of the transmission line 33 kilovolt. So finally after the substitution we'll get the final answer as 20.2 minus J 472.6 ampere. So this is the answer for the given problem, IF double dash actual. So that completes the problem. Thank you.